All right, friends, you are in for a treat. We're talking about what I consider to be the strongest case for intelligent design with my friend Jay Richards, who wrote a book 20 years ago called The Privileged Planet. I have a picture of my son when he was a newborn reading that book, holding him. I was just so engrossed by the argument. I've been waiting for this 20-year update for a long time. Jay and I posted an in-depth conversation about how the argument has changed and adapted, and in his perspective, I agree with, gotten stronger earlier this week. Now we take your questions. And Jay, I sent you a few of these. We'll also take some live ones, but there's some legit, good, thoughtful questions here. We have some from one Muslim weighed in, an atheist weighed in, skeptics, Christians, a range of people. Are you ready to go?
I am. Let's do it.
All right, so maybe as people are joining us, maybe just remind us what your unique argument is, because the objections that I take are not just about God existing, but your specific argument.
That's right. So I think the easiest way to think of our argument is part of a series of design arguments, starting if we let's start with the origin of the universe as a whole, right? So this the evidence that the universe had a beginning in the finite past. So the empirical evidence tells us that, well, the universe hasn't always existed. So it's a really bad candidate for ultimate explanation. So I think there's a good argument for something like theism just from that. Now combine the sort of universal fine-tuning properties of the universe. So basically everything in the initial conditions. So like, how would things need to be set up at the beginning? How would the fundamental forces need to be arranged? What would their strengths need to be relative to each other? What kind of physical laws would you need to be able to build things like stars and elements and planets and people? That's this basic idea of fine tuning. And then you have evidence from design, for design, in my opinion, at the origin of life, which I think shows us a fundamental discontinuity between the rules that obtain in physics and chemistry and what you're dealing with in life and reproducing organisms, which presuppose physics and chemistry, but go way beyond it. Our argument sort of focuses on that middle zone. After the fine tuning of everything, before the evidence for design in life. And we focus on what's needed to do two things, both what's needed to build a habitable planet, what kind of ingredients within even a fine-tuned universe would you need to be able to have a planet that's compatible with any kind of life, that is, any kind of life given the periodic table of the elements that we have in the universe. So they're going to be really tight constraints given what we know about chemistry everywhere in the universe on what a planet's going to need to be like in order for life to be able to persist there. And then this other thing, what conditions would be required to be able to make a wide range of scientific discoveries if you're going to pick one location. Our argument is not that, wow, you got to get a lot of stuff right to build a single habitable planet. Therefore, God exists. That's not the argument. In fact, it's not a good argument, in part because, of course, we have a very large universe, lots of stars, presumably lots of planetary systems and planets. And so, the skeptic could say, okay, given the universe we have, unless it's impossible to build a habitable planet, maybe you're going to get one or two just by a kind of run of the vast cosmic lottery. And so we shouldn't be surprised that there's one or two habitable planets, unless we can sort of prove that it's just statistically impossible. That's also a good point. And when Guillermo Gonzalez and I started to write the book, we realized, okay, that is a bad argument. We got to make sure people don't think that's what we're saying. Argument is different. We say, okay, yes, we think the evidence has continued to point in the direction of rarity. That is, relative to the number of opportunities in the universe, say the number of planets, the ratio of that's going to be a much larger number than the number of planets that can host complex life on it. All right. Whether it's unique, whether there's one, whether there's 3 or 5 or whatever, it's rare. On the other hand, you say, okay, well, that by itself isn't really an argument for design. And I'd say, yeah, that's true. But what if there's something else we could tell you about this picture that would suggest design rather than mere coincidence? That's the other part of our argument. It's the conditions for discoverability, or what we call measurability. And you can think of that as, just as you're thinking about what you need to build a habitable planet, you would compare Earth, right? The Earth situation, because we know it's compatible with life, with other kinds of planets we can theorize or we can observe. That's how we get the sense that, gosh, the range of the sort of conditions for building a habitable planet are quite narrow. Now ask another kind of question. What kind of environment would you need to be able to figure out the kind of fundamental laws of physics, to be able to discern the forces of gravity and how it interacts in the world, to figure out that the universe had a beginning, to be able to figure out the structure of the universe near and far, to be able to get access to things that have happened both in the kind of near past and in the distant past? That would be that's another question. So where would you want to be able to discover all of those different kinds of things? Our argument is that the very places that are best overall for discovery, for science, are the same places where there can be observers to do discovery. And we think it's that pattern, that overlap of the conditions for life and for discovery that we think strongly suggests design rather than mere coincidence or chance or something like that. That's the basic idea.
I love it. By the way, you answered a question that was asked in the comments, and I'll just address it really quickly. Jennifer asks here, could you please maybe give me the top 5 pieces of evidence for intelligent design? Well, you said the beginning of the universe points towards a beginner. The fine-tuning universe points towards a fine-tuner. The origin of life and its information points towards an information giver. And then now we find ourselves in this rare location that not only enables us to have life, but it's the best optimal place to discover the universe in which we live. And there didn't have to be that connection. That's the unique argument.
That's the unique argument. And it doesn't, incidentally, the argument doesn't require, for instance, that God sort of directly put all the pieces together, like directly, or not. The argument's the same either way. However God sort of arranged this, our argument is that if there are any other habitable planets in the universe, they're going to be very much like the Earth. It's going to be a good place to do science. And so our argument is basically that there is this pattern that we can now discover in the universe, in which the rare places where life can exist are also the best places overall for doing science. And it actually took us, we had to get to about the stage we're at in terms of scientific discovery to be able to actually make this argument, because it requires us to be able to compare our conditions and atmosphere and things like that with other planets. And 5,000 years ago, humans didn't have the ability to make this kind of argument because we didn't have the data.
Okay, so this actually brings us to question number 2 that somebody put in the earlier video. So I'll bring it in right now. The person says, I'm not sure the argument about eclipses enabling scientific discovery is a great one for design. One needs to have the implicit assumption that God wants humanity to discover science. Let's grant that. If so, why is it just now, 2000 AD roughly, that relativity has been proved by watching stars during an eclipse? Why now has it taken so long if God wants us to discover the universe in which we live?
Yeah, and so this is sort of presupposing theism, I think. So I'm just going to take it that way, right? That let's assume that a God like the God that Christians believe in exists. Why would he sort of set things up this way? So that it just now, really, let's say just in the last century, have we been able to figure out, general relativity or something like that? You could sort of make this argument about anything. I mean, why did God wait so long to become incarnate? Or why is he waiting so long to return? There's lots of those questions that are, the scripture may speak to it, or they may just simply be unanswerable. And so what we're trying to focus on is, okay, given the kind of the empirical evidence that we have before us, it cleaves in terms of 2 directions. Is our habitable sort of environments more conducive to doing science than other less habitable places, or not? And if it turns out they are, that pattern suggests, we think, purpose. You don't actually have to know a lot about the motives that God had here, just as if we discovered an alien artifact on another planet. Let's say we found on some other planet around Proxima Centauri in the future. It's a very mountainous planet. We went there, nobody's around, but we see a bunch of intelligent artifacts, and we find a really sophisticated telescope on the top of a mountain. We're not going to have any doubt why they put it on the top of a mountain, right? Even if we know nothing about the motives. And so it's really important when you're thinking about design arguments to realize that very often you can detect the signature of intelligence, even if you don't know the motives of the designer, the presumed designer, right? And so that's absolutely crucial. And I think that's true here. Now, yeah, if somebody says, well, there's literally nothing intrinsically interesting about being able to make discoveries, I don't know what to say, but everybody kind of knows that's not true. Just as if somebody said, well, a universe with life in it is no more interesting than a lifeless universe. At some point, you're realizing, okay, this is something important that needs to be explained. And so let's look at the hypotheses that can explain it. Another way of sort of framing the argument would just be in terms of a kind of likelihood in which let's just take two hypotheses. One, the universe is designed for discovery.
Okay.
Two, it's not. Well, the evidence, if we're right, the evidence that we see is much more likely given that the universe is designed for discovery than it's not. This isn't a deductive proof for the Trinity or anything like that, but it's an argument which we think the evidence, the preponderance of the evidence, at least when you look at it, points toward design.
So we're taking questions that people wrote in as comments in the original video. But if you're here live and you have a question, write question in caps. And if it's related and to the point, we'll try to bring it in. Let me take you to a question I thought was really thoughtful that somebody wrote. They said, as I understand your argument, it presupposes our current scientific models. For example, you talk of how the perfect eclipse is useful for providing evidence for Einstein's general theory of relativity. Suppose it turns out that general relativity is false and that a different model doesn't require a perfect eclipse. You get the point.
Yeah.
What would that do to your hypothesis if our entire approach to science right now is wrong?
Yeah, that's a great question. And so what we are basically presupposing without arguing some kind of scientific realist picture. It's not that every theory is true, but that what happens, at least at the sort of large scale, is our theories approximate truth. And so we really do have layered theories. And in fact, we spend a bunch of time talking about this in the book. And so philosophers of science have noted, for instance, that scientific discovery is sort of like a stepping stone. And so in some ways, for instance, we had to develop the calculus to be able to do certain things in science. We needed to be able to develop telescopes, right, to be able to see things that weren't visible to the naked eye. And when we do that, very often, one theory will replace another, but it doesn't normally replace another in the sense that, well, that one was false, now we got the true one. So it's not like Einstein or Newton's sort of views on these things are false. It's that, well, it turns out inside general relativity, Newton's theory is really good for describing a lot of stuff, but you get in relativistic environments, moving close to the speed of light or near a massive body, it's going to break down. And so that's what we need general relativity for. On the other hand, if we hadn't had Newton, it would have been very difficult to get general relativity. And if we hadn't had Kepler, it would have been hard to get Newton. And so this is a sort of stepping stone, right, of a kind of greater theoretical understanding, which we think is, we interpret this realistically. In other words, we think we're getting closer and closer to the truth of things. And we share that. That's how almost all scientists think. They don't just think that you're sort of constructing theories, but that we're getting closer to the truth about stuff. Now, here's the interesting thing, Sean, is that you can actually ask the question about environments for discovery, thinking about this. In other words, you could say, okay, what kind of environments would you need to be able to have taken those steps theoretically from one to the other? And so, for instance, you would need to be able to see the planets in your own solar system. So if you had a murky atmosphere that's 100% murky all the time, or it's just you're in a really cloudy part of the galaxy where you can't make out these little points of light, Kepler and Newton would have had a really hard time ever figuring out what they figured out with respect to gravity. And the same goes with Einstein. So I would surprise me to say, okay, everything about general relativity is false. Because either way, the data is really clear now that, if you measure the starlight passing near the edge of an eclipse, so that's passing this massive body like the sun, the light appears to move. And so clearly gravity, whatever it is, right, is affecting the trajectory of light. And so what I would expect and what we would predict is that if something needs to supersede Einstein's theory, and I'm guessing something probably will, it will be beyond this, that it will incorporate everything that we've discovered, but it'll give us more and maybe clarify some things that are not right. Now, that's one kind of big point. The other thing is that we use eclipses just as one example. So, or the confirmation of general relativity. So eclipses, perfect eclipses like we have on the Earth, they actually are a treasure trove of discoveries. It's just that some of the details are more complicated. So for instance, we discovered helium. It would have been actually hard to discover helium. It was a gap in the periodic table for a long time. It was like you knew there needed to be an element there with that atomic number, but we didn't really know what it was. Well, you can see helium during an eclipse because it's in the atmosphere of the sun that you can't see if you got the bright photosphere of the sun. And for the same reason, eclipses allowed us to figure out the different constituents of our sun, which is a star, and so opened up to us the understanding that we have of all the other stars in the universe. And so you can see how there's a kind of stepping stone series of these. But our argument's not just eclipses allowed us to confirm general relativity, therefore it's designed, right? This is like one part of a cumulative case argument, which is honestly, I say what a cumulative case argument means technically is that you can't make the argument persuasively in 15 minutes because you need to sort of have a time to lay it out. So whenever, we're talking about the argument this way, it's in some ways, it's like, okay, this is a teaser for, there's a reason the book is 444 pages long and has 100 illustrations. It's because we felt, okay, look, if this is true, we want to find this pattern across the scientific disciplines.
Now, one quick comment, and then somebody wrote a question in exactly at the right time, that if in some ways one of your example was overturned and we moved a different direction, our scientific understanding, that could only be discovered if your correlation works, that we find ourselves in habitable environments in which we can make discoveries. So it would advance your larger case, even if a particular is wrong in some sense.
Yeah, that's right. Yeah. If now it depends on what it is, of course, but let's say we discover this new thing. Well, clearly we were in a situation to be able to discover it. Now we would compare the conditions for discovering that with other environments. And so we say, would it have been easier to discover this if we had been around, Alpha Centauri, or we had been on the clouds of Jupiter, right? We can't do that comparison now because that superseding theory doesn't exist. But that would be the way that one way the argument could be either confirmed or disconfirmed would be to have that happen and then compare our environment with others.
Here's one. Minecraft Mom asks, how do you respond to the puddle analogy? Now, I had an atheist in the comment, right? The puddle loves its hole. Saying the earth is special is literally special pleading. As an atheist, this is just a pure example of post hoc reasoning.
All right. So it's not, but this here is I'm going to strengthen the argument slightly, though. So let's say the tadpole loves the puddle that he's in, right? And so really what we wanted, we are an organism within an environment. And so the tadpole maybe looks around and says, oh, gosh, this puddle was made just for me. And he can get up to the edge and he notices, gosh, I wouldn't be able to breathe if I were out there. So it's a good thing I'm here. This must have been set up for me. All right. So that would be a bad sort of selection effect argument that doesn't allow you to infer design. So the tadpole is sort of doing something intellectually illicit there. Now, why? Well, because we know that tadpoles get dropped in eggs. Frogs drop these things all over the place, and the frog is going to drop these in lots of sort of places, and it's going to sort of emerge. Or the example we use in the book would be: imagine dandelions are conscious, and there's a dandelion in a giant parking lot in Texas, and it's growing right in this little tiny crack. And he could look around and say, "Wow, if I had been planted anywhere but this crack, I wouldn't be able to exist. And so somebody must have very carefully planted me there." Okay, why do we know that's bad reasoning? Well, because we know how dandelions work, right? They spread those darn things everywhere. And so some of those seeds are bound to land in the crack. And so there would be arguments that could be bad like that you could make. For instance, if we said, wow, it's amazing that we're in an environment that allows us to exist, so it must be fine-tuned. That is a bad argument because, of course, we're only going to find ourselves in a place where we can observe. That's actually not the question. The question is, if you're thinking about the universe as a whole, why does a universe exist that is so precisely fine-tuned for the existence of life? Especially when we look at it carefully, it looks like a lot of the alternatives, most of the alternatives, are hostile to life. That's an argument for fine-tuning as opposed to just, wow, why do we find ourselves in a universe compatible with our existence? That would be a bad argument. Now, of course, in this case, though, our argument is it's got a kind of a 1-2 punch. And so we're arguing, yes, that the rarity of habitable conditions, that's part of the argument, but that's not the only element. We're not using that to argue for design. we're arguing that it's that the coincidence of that plus the conditions for scientific discovery together that suggests conspiracy rather than mere coincidence. We say, look, that's a telling pattern, or what Bill Dembski calls a specification. And even atheists that I've debated on this on radio shows will concede very often, yeah, if that were true, that we found ourselves in the rare places that were the best places for doing science, that would be fishy, but usually the argument is that we're not doing that. And so this is absolutely not a dumb kind of selection effect argument about the tadpole being amazed in the puddle, precisely because of that. And then finally, also because unlike that poor tadpole, we are able to compare the alternatives. It's not just that we're here in our environment, can't see anywhere else and think, yeah, this seems great. We can actually take the kinds of things you need to be able to discover scientifically and compare how good other environments would be for doing that. So the entire argument is comparative. It's sort of like if you're in a city that's very mountainous, something like Seattle, if you have a good view, the best view, you have the best view. And you can also compare your view to everybody else's view, but there'd be some views that are so bad that people don't even know they're in a bad view. That's our argument, is that we're arguing not only do habitable planets end up being the best places overall for doing science, but they also allow us to discover that by comparing our environment with other environments. So that would be quite the tadpole that could do all those kinds of things.
Fair enough. I appreciate the response. Now, this one is really helpful. This person's looking for some specific numbers in terms of when you listed out the conditions for life. So the right kind of core, the right moon, we have the right tilt, we have the right sun, we're in the Goldilocks zone, all these kind of factors. This person says, have you done any statistical analysis on the probability of all these Goldilocks conditions for life on Earth? In other words, you're telling us it's super improbable. Is there any way to put numbers to this, or is that beyond our scope to do so?
Well, I could say for Guillermo and me, we think we don't want to sort of be artificially precise. And so, for instance, we just don't have a lot of these numbers. For instance, how many stars have a planet around them? How many stars with planets have one of the planets in the Goldilocks zone? Those are kinds of things that, in principle, we'll get enough data that we can make some sort of rough estimates. And we do that with respect to a planet, the sort of number of stars that have planets in the book. So one of the appendices is a expanded Drake equation. And the Drake equation is just basically it's just a multiplication problem in which you multiply the different factors that you would need. Each of those is a number less than 1, and then you multiply it times, say, the number of stars or the number of planets, and then that gives you a number at the end. What's interesting, though, is that even if you don't have precise numbers, it doesn't take a lot to swamp the probabilistic resources of the galaxy, because if you had, let's say, really modestly 13 independent variables, and each had even a 10% chance of occurring, well, that would mean that there's something like, let's say, 100 billion or so stars in the Milky Way. That would mean if it's the probability of getting a habitable planet is 1 in 10 to the 13th, there's only a 1% chance of getting one habitable planet in the universe, in the galaxy. And so that's interesting. And so basically our argument is that what we think is going to happen is that the more data we get, the narrower the conditions are going to become. Now, of course, we don't argue that, okay, if the universe had one fewer proton, right, life would be impossible. The debate is really about, okay, so how rare and how precise do these things have to be? There's a little wiggle room in all these things, obviously. The key thing is that you need the ratio or the contrast between the habitable planets and the uninhabitable planets to be significant in order to be able to say it's rare. That's how you can detect the signal. If there are lots of different ways to build habitable planets and chemistry was not super picky about the kinds of planets, it would be very hard for us to make our argument. But it's precisely because we can contrast habitable environments with basically all the other ones that we know that we feel confident in making the argument. We, more than anyone, would love to have exact numbers on all of these, but we just really don't have them. So we do the best we can in the expanded Drake equation in the end of the book.
I think that gives some integrity to your argument, because it'd be easy to overstate and exaggerate certain numbers to make your case you guys resist that and show that the improbability is so high that that specific number is not necessarily necessary, but you
Yeah.
resist actually giving a specific. I
Yeah.
appreciate that. I think that's helpful.
And it's also that's how we reason in everyday life. So when we
Mm,
detect a text, for instance, right? What we're noticing is that, let's say it's a printed text, the letters, and then the contrast is, or the channel, as information theorists would say, would be the white page. And so you need a contrast between the letters and the page. And then you need the kind of appearance of sequences of letters to be very rare relative to the possibilities in order to be able to code information in it. But none of us do if you find a page of text, none of us says, okay, let me run the probabilities of these letters sort of arranging themselves by chance, right? We're actually really good most of the time at actually just telling. And I think that's really the case here. And so we don't want to, on the one hand, we don't want to overstate the argument. We also don't want to raise the bar way higher than it needs to be when in fact we're pretty darn good design detectors in everyday life.
mm. That brings us to a question in the comments that I think I'll pivot to right now. And by the way, I see a couple of our existing apologetic students. Randall from the class of 2019. Jeff is the class of 2025 in our apologetics class program. Good to have you guys here. Here's a question that relates to this from Alexander Machuca. Sorry if I mispronounced that. He said, could perceived design be an illusion of our mind seeking and assigning order to a random phenomena? So in other words, he's saying, is this possible? And my instinct, Jay, is to always say, sure, it could be, but you got to tell me why this is the most reasonable explanation given the strength of the argument. Where would you go in this question?
Exactly the same way. I mean, it is always possible to harden a particular premise or change a premise in order to maintain skepticism, at least with an argument like this, maybe not with some simple arithmetic. And that's what I think is happening. So yeah, is it possible you're a brain in a vat? I mean, I guess so, but there's no good reason to think that. And there certainly is no good reason to think that that's a better hypothesis than the one that we're talking about. And so that's why I think, yes, you can sometimes, if you could show that a worldview, if it were true, would lead to radical skepticism, that's a good argument against that worldview. But if the materialist hears that, he shouldn't say, oh, okay, I should be radically skeptical. The materialist should say, oh, but clearly I do know things, so maybe materialism is wrong. That's how I think that this ought to work. If the alternative is just kind of radical skepticism, you at least need to have some reason to think that's a better explanation than this, even if it's always in the set of possible explanations, it's out there somewhere. Usually that's not the preferred one.
Mm-hmm. All right. So in some ways we've talked about this a little bit, but this is a helpful way that it's framed. The person says, how do you respond to Dawkins' point, Richard Dawkins, that even as the conditions for life on Earth seem exceedingly unlikely, so it's like he gives your premise number one that we find ourselves in a place where all these conditions have lined up for life. So he concedes that premise. Yeah. The vastness of the universe means that it's not impossible for the Goldilocks conditions to occur by chance. So to explain this away, atheists, as you know, or skeptics, are going to have only so many explanations. It could be necessity, it's required. It could be chance or some combination therein. Dawkins says vastness of the universe, it's going to happen somewhere else by chance. We don't need a designer.
Well, and that's his argument, if I recall correctly. Dawkins sort of uses that argument for the origin and evolution of life.
That's right.
And there's a legitimate element to this, right? So unlike multiplying alternate universes that we can't observe in order to explain the way the fine tuning, you're not explaining things away to just point out that it is a big universe. So in other words, the universe isn't so fine-tuned that it determines the outcome in every little detail. There is a lot of variation. And so in any kind of argument we make, it can't just be, gosh, the conditions for a habitable planet in the universe are quite rare, therefore that's design. The example I often use would be the coin flip, right? If I say, okay, I'm going to flip this quarter 20 times and get 20 heads in a row, and you see me do it only 20 times, you're going to assume that it's a fake coin or two-headed or something. On the other hand, if we sort of lock everybody in a room and I say nobody leaves until I get 20 heads in a row, maybe in a few weeks or whatever, I get 20 heads in a row, you're not going to be astonished at that point. And the reason it's the same event, 20 heads in a row, but the opportunities for chance to operate are much greater in the second case. In the same way, in the universe, yeah, let's assume there are 10 to the 11 stars in the average galaxy and 10 to the 11 galaxies in the observable universe. That's a lot of probabilistic resources. But our argument isn't that the conditions for life are rare, therefore the universe is designed. It's this pervasive pattern that those places where life, the rare places where life can exist, find themselves in the best places for doing science. And so we think that's the pattern that actually that actually sort of should trigger the design inference. As a result, though, notice that our argument is not that Earth as a habitable planet must be unique. We could find other environments like Earth, but an implication of our argument is that if we do that, those should be very, very Earth-like. These are not going to be radically different Star Wars planets with life on them. They're going to look a heck of a lot like Earth in its details. That's actually a prediction of our argument. If we find other habitable planets, they will look very much like Earth.
So that really challenges the idea. One of the objections that somebody wrote is that your argument is impossible to falsify. If you can't falsify it, and you're saying if we find life, and by the way, you make a distinction in the book between simple life, complex life, and technological life. When you say if we find life on other planets, it'll be similar to here with this correlation between habitability and measurability. Are you referring only to technological life, complex life? Flesh that out.
No, definitely. And so because the conditions needed for technological life are so much narrower than they are for what we're saying simple life, so like a single-celled reproducing organism, it's possible that there'd be more places conducive to simple life than complex or technological life. But our argument's really that if there's other technological life in the universe, they will be, at least their native planet will be very, very much like the Earth. I mean, so much so that it will be roughly the same size and mass, the same elements, probably around the same kind of star. It will be a mix of continents and oceans. It will have a stabilizing moon. It will be, of course, it will be in the circumstellar habitable zone, all those kinds of things. And it will be more like Earth than Mars is, because Mars is the most Earth-like planet other than Earth that we know of. And it's lifeless. So that tells you that, gosh, it looks like you got to get a lot of stuff right, even to have the chance of having life on a planet.
Good stuff. Now, I saw a comment that said in here, you're claiming your thesis is impossible to verify or disprove. You're actually saying the exact opposite. You've laid out predictions. And we talked about it in the last video. You had predictions 20 years ago. Some of those have actually come true in light of your hypothesis. If they didn't, it disproves your theory. So
that's right.
Falsification is
here's
built
an easy
in.
way to falsify. You can come up with all sorts of scenarios. A really good way to falsify argument would be to find technological life that's as complex as we are around in a completely different star system and on a totally different kind of planet, or life that's based on a completely different type of chemistry than earthly like. All of that would put just a do major damage to our argument, and I think it would, honestly, it would basically falsify it. And so, just like any of these arguments, these kind of macro arguments about the universe, they're going to be things that can confirm it. And you say you want to try to make predictions to do that. The falsification conditions are usually kind of harder to get, but if you can find a falsification condition, it really gives you a lot of certain information. And so, I joked when we did our interview earlier that, if we started getting transmissions on a radio signal from another intelligent civilization, the first thing we'd want to ask them is, send us some pictures of your perfect eclipses, and we could send some of ours.
Now, I see there's a number of questions here moving from this to Christianity. Let's hold off on that because I want to make sure some of these objections we cover first. Now, there are sometimes theological questions people raise. Why didn't God do this? In some ways, we don't know unless God tells us. We can only speculate. And whether we know or not doesn't overturn the thesis you're laying forth. There's scientific objections. Here's one that's more of a sociological question that really doesn't get to the heart of your argument, but maybe kind of suspects that if the argument were as strong as you think it would, more people would believe. So let me pull this one in. This comes from a skeptic. I think identifies as an atheist. He says, "Why isn't
Mhm.
a design cosmos the consensus of science today?"
Yeah, that's a great question. And but it would depend on why are we specifying today, right? Like, what's the relevant time horizon? And if as it happens, even now in 2024, for I think it's Pew has been doing, or Gallup has been doing polls of religious belief or belief in God among scientists, and it turns out it's mathematicians and physicists that are always, about half of them persistently believe in God, whereas it's actually sociology and psychology where it's really, really bad. And that is a kind of sociological question. And my general account would be that for the majority, certainly of Western history, design has in fact been the consensus view. Starting in the 19th century, the kind of materialist assumption sort of moved to the front, even though it's still not a majority view among the human population, let's say among natural scientists. But this is a real question. Like, okay, so if the evidence from science for design is so good, why isn't it that the very people that study the natural world doing science don't see that? I think it's because of philosophical assumptions. I mean, we know that all of us are always in danger of the power of the paradigm. That is, the assumptions that we make we just sort of treat them as obviously true. And so we don't really test them. We don't really go out looking for the best, strongest arguments on the other side. And so I think that's what happened in the 19th century. There was this sense that, gosh, we can explain almost everything just in terms of purely mechanistic laws and things like that. And with Darwinism, that looked, if you take Darwin's interpretation of it as if that kind of substitutes for a designer. So it looked like, okay, we're explaining more and more stuff without invoking the existence of a God. So we just don't need to do that. I don't actually even think that's true historically if you look at what was happening. So for instance, just the very idea of a law, what happened is that theists, because they were theists, had this idea of an orderly universe that conformed to something called laws. And they're all very explicit about this. If you look at the founders of the subdisciplines of modern science, well, then what happened is that the law gets sort of abstracted from its metaphysical context, and it's just sort of it's treated as if it's a given. Well, I don't think atheists, it's not like they get to have gravity in a lawful universe. We observe a lawful universe, and there's no reason to think that a lawful universe is more likely on materialism than on theism. And so I think the answer is it's a kind of complicated mix of sociological dynamics over the last 150 years in which there was an interpretation of what was happening that, it essentially propagandized for materialism. But I think that said, there's never been a better time to be a theist based upon what we know about the universe. It was only in the 20th century, for instance, that we really got solid evidence that the universe has an age, right? That we didn't just have to believe that because the Bible said it, but in fact, it seems to be true empirically. That's really profound. But these cultural shifts, I think that they happen really, really slowly. So I think what we're doing is we're talking about evidence that's very exciting and points in the direction of theism, but most people still don't know about it. And so that's just the kind of bitter reality. I wish everyone at least knew the argument in its depth, but they don't.
Well, we're trying to get the word out here. So even if people reject it, at least they can understand it and wrestle with it. That's one of the most important things. Friends, if you have comments, write comments in cap, state it as succinctly as you can. And if it's related to the hypothesis here, we're going to give it to Dr. J. Richards to respond. Here's in the back of your book, you and Guillermo Gonzalez, I think you had like 12 or 15 of objections you anticipated ahead of time and responded to. Now, there's still a few of the comments written in that we're going to come to, but I flipped back there and thought I'd ask you one or two of these because these are some of the common ones that I've been heard as well. And somebody writes this. They said, you're cherry picking. You have a biased sample to argue for correlation. So if you look out, you found a few that fit your pattern and ignore those that don't.
Yeah, that's a great point. And we were acutely aware of that at the beginning. It would be easy to just come up with a couple of cool examples. And so that's why we decided, okay, what we're going to do is let's sort of delineate the relevant disciplines for which a kind of physical environment would be absolutely crucial. And then at least abstractly try to consider, okay, what would the kind of things that you would need to discover in any kind of environment, right? Like, in other words, just in the abstract, Well, you'd want to be able to know, is the universe finite or it's infinite, or is it eternal, or does it have an age? You'd want to be able to sort of understand the macro structure of the universe and the bodies within it, but also the kind of small scale stuff. It turns out that if you want to see both, detect really small scale stuff and really big scale stuff, there's actually an optimum size that you need to be. If you're too small, you won't be able to see the big stuff. If you're too large, you won't be able to see the small stuff. We're in a situation, weirdly, our size scale is such that we're able to actually detect the macro structure of the universe and get all the way down to detecting quarks and neutrinos and things like that. And so those are just the kinds of things that you'd sort of want to ask yourself. You could always say, well, would there be, if you were someplace else, there might be something that we could discover there that we couldn't discover here. Yeah. But at some point, if you have enough examples, I mean, you don't realize, but so much of what astronomers do, we're actually able to sort of anticipate theoretically, okay, what would it look like on the surface of a particular planet, given what we know? Mm-hmm. And that's absolutely crucial, that we're able to learn the basic laws of physics, the constituents of the physical universe, namely the chemical elements and all the various compounds, from our location, tiny location on the Earth. And yet that gives us universal knowledge about the universe as a whole. And so at some point, what seems to me to be special pleading is to just keep asserting that, oh no matter how many examples you give me, I'm going to accuse you of cherry picking, even though I can't think of any other examples. Cherry picking would be, okay, here's the 12 best examples we can come up with, and you're emphasizing 3. We'd need to really, I think, make the objection forceful. Somebody would need to say, here's a bunch of stuff we could discover if we're in these other places that we can't discover here. And there's 30 of those and 12 of these. But that's part of why, Sean, we spent so much time kind of going across the disciplines from geology to different kinds of astronomy and physics, precisely to try to show that, look, there's just a lot of examples here. And we're not picking weird little side-like obscure discoveries. Confirming general relativity or figuring out the structure of stars, that's a really basic thing.
Are there any outliers that you guys don't know what to do with that just challenge your thesis in some fashion? I think of like J. Warner Wallace, our mutual friend, cold case detective. He's like, when you have a case, you have the evidence that's sufficient to show somebody is guilty beyond a reasonable doubt. But now and then there's still factors that we don't know how they fit in. They're not enough to overturn our entire case. We just don't have enough data, so to speak. Are there some findings that you guys look at each other and go, I don't know how this fits in, not sure, seems to challenge our thesis, but we don't think it challenges our overall thesis? Or are there literally no outliers that challenge your larger claim?
Well, so it would be things like, okay, if you take just a single example, right? So let's say you wanted to find the best place for detecting the cosmic background radiation. Well, it wouldn't be on a planet with an atmosphere. It would be between galaxies, right? Where it's really dark and there's no atmosphere. Okay. And so that, somebody could say, okay, well, that challenges because, right, your argument, we're stuck here on a planet with an atmosphere near a sun. But our response is that, our argument's not that on every metric it's as good as it can get, but rather building a planet is like building a laptop computer. You want constrained optimization in which you find the best compromise of all these kind of competing conditions. But at some point, if you just came up with an example of a place that actually, I can think of a place that would be totally hostile to life, and it would be much better for discovering, 12 of the 30 things you described. That would be a problem. The thing that I would say is an outlier, it doesn't sort of contradict our argument, it's just that we don't know how it plays in, would be, so for instance, like all the planets in our solar system. So we think there's good evidence that having some gas giants out in the outer part of the solar system, it helps protect the inner part of the solar system where Earth or Earth-like planets would be. Okay, what about those gas giants? What about Pluto? What about the asteroid belt? What about having a Venus and a Mars really nearby? At the moment, we don't have any account of that at all. It's just that there's a kind of a general point about the need for these gas giant planets, but we don't know about those other things. But we think that's okay because there's a bunch of stuff that we didn't understand 100 years ago, and there's probably always going to be a bunch of stuff that we don't understand. But in a highly discoverable universe, it's actually what you would expect. you'd expect that there's actually more places to discover. It's just like a really good part of the country for doing hikes. It's like you can never tap out all the hikes, and I think that's what we're dealing with here. It's like, okay, maybe all these things actually play a crucial role, and we just haven't figured that out yet.
This is actually one of the questions that somebody said. They said, is it true that our solar system is necessary for life on Earth? In other words, they clarify, do we need all of the planets and our moon for life to exist? Why would God require all of them? It seems like you're saying we certainly need some of them. We don't know if we need all of them in that fashion. So do you look at this, Jay, like the argument about, say, DNA, and there was what was the term they would use? Like just useless forms of
Junk
DNA.
DNA.
Yeah, junk DNA. Molded by a Darwinian worldview that says this was cobbled together purposelessly, no design behind it. So why look for purpose? And it was actually a prediction of many intelligent design proponents who said, wait a minute, as we probe further, we will find purpose. And it's remarkable how much of junk DNA has been found to have other purposes. You look at the solar system in the same way and say it's probably out there, and we suspect it is, or could there be things that just serve beauty and other purposes?
Well, and I think beauty is actually one of the purposes. I don't have any reason, I have no theological reason to think, okay, God did, the only purpose he had was to have observers, right, in the universe, or to be able to have astronomers. I think of God when he shows up at the end of the book of Job, after Job's friends are all telling him, well, you've obviously sinned, and so God is punishing you. God shows up and he doesn't really answer anyone. He's just like, where were you when I look at the Pleiades and Orion, look at Behemoth and Leviathan. In other words, God's got a lot of stuff going. And I assume that God has a purpose. He does. He has a purpose for everything he does. But it may be that some things are just there for their beauty. I mean, I honestly think there's a lot of stuff in the plant and animal kingdoms. These birds of paradise. Of course, Darwinists always kind of have a sex selection argument for these things. But as a Christian and a theist, I think, why couldn't and wouldn't God just create things because they're beautiful? That surely is a possibility. And so, theists should be open to a much wider range of possibilities, I think, that a materialist would be.
That's helpful. Now, I'd love some comments from folks watching this as well. I have not done many live streams in a while, and I've thought about one of the neat things I can do with this channel is bring on scholars to make arguments, maybe in intelligent design, archaeology, do an interview, take your questions, and then bring them live and respond like this. If you'd like me to do this more with scholars, just comment below things you might change, ideas for it. This would help me figure out kind of the future of the channel, so to speak, where we're heading here. Okay, let me ask, this one keeps coming up here, and let me pull this, let me see if I can find this here. A few people have been asking kind of the connection you think from design to faith itself. Now, here's the way it's worded. This is from one of my former students in our MA Apologetics program. Graduated 2019. You made it out before COVID. Good job, Randall. He says, and there's an assumption in this, you can agree with it or obviously challenge it. He says, what makes Christianity more compatible to the design cosmos idea than other world religions?
Well, and so it would depend on the world religions, I suppose. And so I'm going to I think everything that we argue in the Privileged Planet would be compatible with any theistic religion, basically. So if your religious views include a single God that transcends the physical universe and on whom everything depends, this is going to be compatible with that. Now, argument, I don't think gets you all the way to theism, but it's consistent with it. On the other hand, if you're a polytheist, or let's say you're a Zoroastrian, right, and you think there are these fundamentally sort of opposed principles that are of equal power behind things, I think it's going to be less compatible with that, because we see a universe that's orderly all the way out. That's what's sort of extraordinary. That was an assumption of the early founders of modern science. And so that's why I think it's not a coincidence that science emerged in a Christian context where people believed that God was good and that he was rational, right? In the beginning was the logos, was the word. I think that's the clear example where theological assumptions in a culture actually led to institutions like science. And so that would be, I would say, it's most compatible absolutely with theism. And in fact, I think if anything, it actually kind of confirms theism in a sense. Less compatible with a kind of polytheistic view or Zoroastrianism, where you have this fundamental
Mhm.
dualism, and not compatible with materialism. So any religious belief or metaphysical belief that insists that the cosmos is all that is and ever was and ever will be, and ultimately there's no real purpose, there's no teleology in nature. Argument it's mainly designed to as a critique of that. That's the sort of the main alternative to our argument.
That's helpful. So I've got a couple more for you here that people are writing here, which is helpful. And this one, I don't want to spend too much time on this, but maybe just give us the sense of where you would go from this. This is from a
Okay.
Muslim listener. He says, as a Muslim, I agree the evidence for God is stronger. Seems like he says amen, or however a Muslim would agree to that, saying, I agree with you. Good argument, Jay. But then he says, but also the evidence against Christianity is stronger. The entire Bible's been fabricated. Even though we love Jesus, but he's certainly not God. Now, I don't want to spend too
Mhm.
much time criticizing that, but I'm just curious how you connect
Yeah.
what you believe to your Christian faith and broadly respond to something like this.
Yeah, absolutely. I mean, the thing that distinguishes Christianity from just a bare theism is that we believe that God not just created the universe, but he actually entered into it. That he, in this mysterious way, in the Godhead, the second person of the Trinity was able to become incarnate, able to become a man, in order to work out his plans for salvation for humanity and actually for the universe as a whole. And so what that means is that there's a historical component to Christianity. There just is an irreducible historical component. We claim in the Old Testament that God,
Hmm.
he chose Abraham and the Exodus, and so there's this kind of historical claims in the Old Testament, and then preeminently in Jesus Christ that he was born at a particular time, he was crucified, and he rose from the dead and then ascended into heaven. And so you could have good or bad evidence for that. And so if you want to talk about that, you'd have to turn to, okay, what would be the kind of evidence we would need? We're going to need sort of reliable testimony and reliable documents, because that's how we know about things in past history. And if you do that, you look at the manuscript record for the New Testament texts are just utterly extraordinary. In fact, there is nothing like them. The knowledge that we have, for instance, of Aristotle's writings and Plato and most of the ancients, which scholars are not skeptical about, we think we basically have those texts. Those are a pittance compared to the manuscript history we have of the New Testament. And with the Dead Sea Scrolls, we've now confirmed an amazing sort of transmission of Old Testament texts. And so I think if you're going to get to Christianity, you want to have both these kinds of natural reason arguments for theism and against materialism, but you also have to make the historical case that the New Testament record is reliable, that the say of Christ's resurrection explains things that aren't explained otherwise, and so forth. And so I just disagree that the Bible has been sort of shown to be
Mm.
fabricated. In fact, I'd say if we use reasonable standards for historical texts, we should have more confidence in the reliability of the Christian text of Scripture than we do of almost any other historical event, that we're talking about a couple thousand years ago.
Some people have criticized intelligent design because it doesn't get us all the way to the God of the Bible. As you know, I wrote a
Mhm.
book on intelligent design with
Yeah,
Dembski in 2008. And I think that's such a weak response. I like intelligent design because I think there's certain integrity where people say, here's a pattern we
mhm.
see, here's what we can actually conclude from it. Now, the
Yep.
follow up question is uh, if this mind or designer exists, has this God spoken? That's
Yeah.
where, as Christians, say we've got to take the
Mhm.
next step. Did Jesus claim to be God? Did he walk on
Yeah.
water? Can we trust these scriptures? Did he rise from the grave? That's a subsequent historical question that follows from this. But the mere fact that your argument doesn't get us there doesn't mean it doesn't have value insofar as it goes. Now, let me.
Absolutely, and that's true. I mean, that's true of any argument, right? I mean, look, if you were going to abstractly say, what kind of argument would you like to have? Well, I would like to have an argument starting with the law of non-contradiction that deductively proves every claim in the Nicene Creed. That would be awesome to have an argument like that. But the world is as it is, where our mental and intellectual abilities are limited. And so let's just follow the evidence as far as that base of evidence will take you. And I think intellectual integrity just requires saying, look, it gets you this far. you're going to need something else to get you the rest of the way there. But that's much better than overselling an argument and saying it proves something that it doesn't.
All right, Jay, we're running up against the clock here, but I want you to steel man a naturalistic response to your hypothesis. So if you did not embrace it, for whatever reason, change your mind, what would be the best objection that you would give to the privileged planet hypothesis?
I've always thought that the selection effect arguments are the potentially the most powerful. That okay, well, you're sort of trapped in this epistemic box in which you can only observe the things that you can observe, but you can't observe the things that you can't observe, and so you're basically imprisoned to that. I've always thought that general form of argument was always the one that was most formidable, which is why we spend so much time saying, oh, in fact, we can figure out what it would be like to observe from another place. But I've always thought that's the strongest one. And it's the one that requires, I think, the most explanation to get around. Some arguments like, oh, well, it can't be falsified. That's super easy. Just find life somewhere based on some different kind of chemistry. It's not hard. I can do that. But the selection effect arguments I've always thought are the most powerful. And they're also the most powerful arguments to deal with the fine-tuning objection. The good news is that people that really, as you know, people that work on the fine-tuning argument, they don't commit those fallacies. It's just that those, if you're not careful and you're first kind of playing with these arguments, you might actually make that mistake.
Jay, does your argument take faith? Because some people say, well, you got to have faith to believe. And of course, we have to define it. But why isn't this just a religious argument rooted in faith of maybe something you wish or hope were true?
Well, and so I would say any good argument for design that's not simply a theology of nature where you presuppose your religious belief and then kind of work out the implications. But a good public argument is just going to be an argument that appeals to a base of data and science that's publicly available. So it's not private revelation. It's not my sort of unique experience. We're talking about stuff that anybody can go check out, right, in physics and astronomy. And so the base of the evidence is entirely public. It doesn't require any kind of sectarian religious belief. And then the logic that we use to get to the conclusion of design is really standard reasoning that people use all the time, every day. In fact, every time you read a stop sign, you're inferring design. And so it's not like we're appealing to some kind of eccentric or parochial base of evidence, and we're not appealing to weird esoteric modes of reasoning. It's public evidence and widely used methods of reasoning to the conclusion. So that's why I would say, you don't have to have faith on it. What you need is the willingness to be open to the evidence that the universe is designed. But if you're at least there, I call that the kind of rational, objective fence sitter. I would hope that our argument, once it's well understood, would persuade that kind of person.
Fair enough. Did I miss anything? Are there any other objections that you hear that you want to weigh into? I think we pretty much, the ones that were related to the topic, there were a ton of interesting questions that people had that didn't quite fit the topic. And I'm so tempted to go down those roads and address them because there's important questions that are raised there. But any other big objections you hear, any other piece of argument you want to put forth?
I mean, a lot of people mistake our argument as an argument that the Earth is unique, and that, in other words, it can only be one Earth-like planet. So that if we discover another Earth-like planet, somehow that refutes our argument, that's a mistake. The related issue would be the existence of extraterrestrial intelligence. Is there intelligent life elsewhere in the universe? Now, I think at the moment we don't have any evidence or really solid public evidence that exists. But Guillermo and I have always treated that as a sort of empirical question. We think, okay, we don't know from Scripture. There's no real evidence for that. But God is the God of the universe, and so he can do what he wants to do. And so we think, look, if there is life elsewhere in the universe, let's be open to it. But we don't assume one way or the other. But I mean, if you think God created the universe, God can do lots of different things. He's not using limited resources. He's not wasting space by putting life in one place or in lots of places. And so there's sort of interesting theological questions there, but I do think that we're perfectly happy leaving that as an open question.
Love it, Jay. This is fun. Told you how much I enjoy your book. I hope folks will pick up the 20th anniversary of The Privileged Planet. I think we put in a link below. If not, you can find it on Amazon. Go to theprivilegedplanet.com. There's a ton of questions of people that either didn't, I think a lot of people didn't really understand the argument that you're making, and that's
Mhm.
understandable to one level because it's a layered argument. But there's a whole lot of straw men I've seen of people dismissing an argument you're not making. So,
Yeah.
believer, Christian or not, at least take the time to understand the argument on its own term and make sure you dismiss it because you find some fault with the argument itself. That would be my encouragement. Jay, we will do this again. Keep up the great work. Hopefully sooner than 20-year update. Of course, we'll have you back.
Absolutely.
But appreciate you carving out the time. And for those of you watching, if you want to study this in depth, we have a full, in our bioapologetics program, we've had a few of our grads engaging here, which is awesome. We have full classes on intelligent design where we talk about this in depth and discuss and debate it. Information below, but would love to have you in our Talbot apologetics program. Check it out. Jay, we'll see you soon, my friend.
Thanks, Sean.
All right. Make sure everybody else hit subscribe. We'll see you soon.